Next speaker is our own Ahmet Kolus, who's going to present a little bit on some of the evidence we've been digging out from the literature on the human factors quality relationship.
So today I'm going to talk about empirical evidence on the linkage between human factors and production quality. So as you noticed from the previous presentation, that product and service quality depends upon many factors, including both technical and human aspects. Previous studies have shown a relationship between human factors and product and work quality. So understanding this mechanism of the relationship between human factors and quality will help us to achieve the full benefits of ergonomics to improve production quality and overall profitability, in addition to the health and safety, of course. So these are some of the comments and observations from the current industry. I tried to gather these points from the literature and confirm them by talking to some of the ergonomists. So during the past 30 years, ergonomics has had a problem of being accepted by business managers. Too few ergonomists work in companies, and even those, they have no control or little maybe control on budgets and people. Managers generally associate ergonomics with health issues rather than with organizational effectiveness. Now, what are the reasons for this current situation? These are some of the reasons. System decision makers, such as managers and owners, they are not aware of the value of the human factors. The benefits of ergonomics are not well documented. Ergonomists hardly ever write articles on ergonomics in business and management journals, and ergonomists presume that others are convinced of the importance of ergonomics. So with this current situation and with these reasons, we try in our project to emphasize on this point. We try to gather all the empirical evidence that proves the potential of human factors, that it could be extended to more than just health and safety, and it could actually do more into the production quality and productivity and cost effectiveness. So what we did in this project, we conducted a scoping review in a systematic way. The scoping review documents what's already known. It identified the gaps in the knowledge, and it sets the scene for the future research agenda. These are the steps, the 4 steps for the scoping review. You identify the questions, the research questions that you would like to answer, and the scope of the review. And then you set up the research strategy, and then you develop initial screening tools, and maybe a secondary tool to filter the studies. And then you extract the relevant information from the selected articles to answer the research questions. These are the 4 research questions that we wanted to answer through our systematic review. We would like to know is there a relationship between human factors and quality? And then if there is a relationship, then what is the main human factors or the main characteristics that may cause quality deficits? We wanted also to understand the mechanism by which these factors cause poor quality. And we wanted to identify the research gaps for future directions. The scope of our review, so basically we focus on quality and human factors in manufacturing context. This will exclude healthcare, service quality, software quality, and air quality. This is our search strategy. So first you identify the databases that you're going to use. We used Compendex, Inspect, Ergonomics, and then you set up the keywords that you would like your search to detect. These are the set of keywords. And then the total hit we got after conducting the search was almost 4,200. After a couple of screening processes, this is the final number of articles we have, 73 journal articles that discuss the relationship between human factors and quality. This is the type of information we're looking for in those articles. We're looking for type of industry, type of work, what's the objective of the study, what's the ergonomics factors or the task characteristics, the task demand, is fatigue as an intermediary factor in the relationship, human errors and quality, and if there is any interventions and improvement. Now, this is a descriptive figure of the results. It's, if you see on the horizontal axis here, it's the percentage of studies. On the left-hand side, you will see the journals. And on the right-hand side, you will see the industry. This is a descriptive figure of the information or the shown in our studies. We wanted to show here in the green color that the majority of the studies, the 73 articles, came from ergonomics journal papers. Mainly, you will see here human factors and ergonomics in manufacturing and service quality, with almost 27% of the studies. And then you have the Industrial Journal of Industrial Ergonomics with almost 18% of the studies. Here, I wanted to point out that very few management journal papers appeared in our search: Production and Inventory Management Journal, Journal of Operations Management, International Journal of Technology Management. On the right-hand side, the yellow bars shows what's the most frequent industry appeared in those papers. You can see that the car industry appeared the most with almost 28% of the studies, followed by electronics industries. These are the simulated lab experiments with almost 11%. This is a free open source concept mapping application. We use this to show the complex relationship in a graphical presentation. I'll try to open the program. So this is our final summary of all the 73 articles. We wanted to explain them in a graphical way so that you can see how complicated is the relationship. So on the left-hand side here, those boxes represent the human factors that were detected in our search. And then on the right-hand side here are the system output or the quality in our situation. In the middle, you will find human effects, such as excessive workload or fatigue. Each arrow here, so each arrow will go from a human factor to human effect and then to system effect or quality. Each arrow represents a study. I'll make it bigger. So each arrow represents a study. If you want to get any information related to any factor here, you can just click on the article number here and it will take you right away to the article so you can find more details. As you can see, we have so many factors here, almost 204. So we wanted to categorize them. So we did based on 4 categories: product, process, and then here workstation, and then individual factors. We try to make this categorization based on the common design activities in manufacturing. It gets crazy now. So this is a picture of what I just showed you. Here are, let me remind you again, on the left-hand side are the human factors, or you can call them task characteristics that were identified in the search. 4 main categories: product, process, workstation, individuals. And then in the middle, human effect, and then system effect. Mainly, our concern is the quality. Here we have some of the statistics about what we just found. So this is the 4 main categories. You can see that 80% of the studies discussed process-related quality risk factors. Those human factors, I'm going to call them quality risk factors because they have an effect on quality. So you can see almost 80% of our studies talked about process-related quality risk factors. 42% product-related quality risk factors, and then almost 37% discussed quality risk factors related to workstation. And then finally, 18% discussed individual risk factors. This figure shows the type of workload appeared in our search. You can see almost 19% discussed physical workload or related physical workload to quality deficits. 8% talked about psychological workload, and then muscular, 5%. You will see here maybe there are some similarities, like psychological and maybe cognitive. So here we wanted to present the data as they were found. We wanted to present the terms as were detected in the terms. Again, here in this figure, I just wanted to mention that this does not necessarily mean that process-related quality risk factors are the most important quality risk factors. This just shows that the literature mostly discussed this type. Here we have almost 28% of the studies relate human errors to quality, and 26% of the studies relate decreased performance to quality. Here, I want to show you what do we mean by process, product, workstation, and individual. So if you consider those white bars, these are subcategories of the product quality risk factor. It includes load, such as force, for example, or postures, and then difficulty of the task, and then task characteristics, like repetition, and then the complexity of the task. The process-related factors, you can see they're related to instructions and procedures, management, policies, training programs, time and pace, relations between workers and management, production philosophy and production systems like lean production, just-in-times. And then the workstation involves tools and equipment, space and reach, and conditions like light and noise. And then the individual factors involve professional capabilities such as skills and experience and personal features. So you can see mostly almost 42% of the articles involved quality risk factors related to instructions and procedures. Here I wanted to discuss each group individually, so I focused only on product-related quality risk factors. As I mentioned, it involved load, difficulty, task characteristic, complexity. In the load, you can see examples of posture, weight move, force, precision and accuracy. And then in the difficulty, you will see task difficulty, viewing distance, tiredness, monitor size, image features. In the task characteristic, repetition, static work. And then in complexity, you will see task-related factors and design-related factors. In the middle is the human effect. So in the beginning, there's workload, could be physical, cardiovascular, psychological, cognitive, muscular. And then there is fatigue, visual, and unspecified. Here, these studies, they did not measure fatigue. They just mentioned in the paper that a reason for poor quality could be fatigue due to poor ergonomics without measuring it. So you will see some of the arrows here goes directly from the quality risk factors to quality. Some of them, they pass through human effects and then go directly to quality. Some of them pass through errors. Let me consider an example here. So this is a study in 1995 by Jürgen Eklund. It's an interview study where he wanted to evaluate the ergonomics condition, the impact of ergonomics condition on quality in car assembly. He identified several human factors or quality risk factors. One of them is posture, poor posture. He showed that poor posture may cause excessive physical workload and will lead to fatigue, which will increase the frequency of quality deficiencies per task. This is the second group, which is process-related quality risk factors. So here, this is the first subcategory, instruction and procedures, such as work procedures, organizational-related factors, forms of instructions, method of inspection, anything related to instructions and procedures, and then relations between workers and management, production systems, management policies such as training programs, wage policy, and then training programs, and then factors related to work pace and time. Similarly, you will find some of the errors goes through human effect, some of them directly goes to quality. The main human effects here are psychological workload, physical and cognitive, physical and muscular. And these are the four fatigue kinds that were identified on these papers: upper extremities, visual, unspecified, mental, and physical. An example here would be a study in 1993 by Parenmark. He investigated the impact of ergonomics on sick leave frequency, labor turnover, and productivity. Same thing, he identified several human factors. One of them was the wage policy. So he found if we replace the typical work policy with age-related policy, so we added that increment, the age-related increment to the wage policy, and then he found that with this new wage policy, the muscular load will go down, the error will go down, and the quality will improve. This is the third category related to the workstation. It involves tools and equipment, such as equipment shortages, fixtures availability, types of tools, tools design, work height, and then space and reach. Components, are they within reach? Switches and keyboards, space to rest the arm, and then conditions related to environment, lighting, noise level. These are the three workloads that were identified. This is the muscular, visual, unspecified fatigue, and then everything feeds in the quality box here. An example here, in 2010, a study by Kolus. It's a cost-effectiveness, cost-benefit analysis of the ergonomic interventions in production. In this study, they found that adding more fixtures to tilt the product in the right position will help to reduce the physical workload and will improve the product quality. This is the last category, which is related to individual quality risk factors, professional factors, training, skills, experience, and then personal, age, personal capabilities, mental condition, physical conditions. You will see that here there is a direct effect on the system, either through error and then quality or directly to quality. This is an example in 2010 by Gomes. It's a cost-benefit analysis of the socio-technical intervention in a Brazilian footwear company. he found that utilizing the skills of employee, the multi-skilling of employee, will improve the product quality. In this figure, I wanted to show you the relation between quality risk factors and workload. What kind of quality risk factors will cause what kind of workload? So if you want to know what kind of quality risk factors might increase the physical workload, for example, you can see that load and difficulty and tools and space are the most frequent variables or factors. If you want to know what causes the cognitive workload, you can see that personal and professional features. You can see management instructions, complexity, and load. All these human factors, they cause excessive cognitive workload. Here, it's the same figure, but with the relationship with fatigue. So you can see the majority of the factors were related to unspecified fatigue. Basically, fatigue was not measured. Here, if you want to know what causes visual fatigue, for example, in manufacturing, studies showed that difficulty of task and task characteristics, time and pace are, these two are the most frequent causes. Again, this figure does not mean that these factors are the only factor that might cause this. It's only represent what was found on the literature. This is a summary table of our findings. So I wanted to show you here how we arrange the information. So on the left-hand side, you will see the reference with a small description, and then you will see what type of industry, and then the quality risk factors that were identified. You will see the human effect, the system effect, and you will see the effect size. This actually is a very important column here, the effect size, because it shows how effective will be if you change the ergonomics. What's the effect size? Is it worth it to invest in the ergonomic or not? Let's take the first example here. It's a Jabberish paper, 1999. It's experimental lab study to address the influence of viewing distance on inspection performance. So the quality risk factor or the variable was the viewing or the task difference. So in this lab study, they tried to increase the viewing distance of the screen. It's an visual inspection task. They tried to increase the distance from 20 centimeters to 60. Then they found that there is a reduction in visual fatigue. They found there is increase in the inspection performance of 124% increase in number of inspected lenses in an 8 hours workday. They found 60% reduction in inspection time per lens and 18% reduction in visual fatigue. So with this ergonomic change here, they found improvement in human well-being and in productivity. So after showing the main human factors and their grouping, here it's, I call it empirical driven framework. It just summarizes everything in a simpler graph. So on the left-hand side, you will see the human factors or the ergonomics, and then you will see the human effects and then the system effect. Here, this is a typical operation systems where the inner box shows the design part of this operation system. In the design part, in a normal manufacturing industry, you will find this is the typical design activities: product design, process design. So our quality risk factors, identified quality risk factors, will fit here. So this is the quality risk factor related to product, related to process, workstation, and individuals. So studies showed that almost 55% of the studies showed a direct relationship between the human factors and quality, while 45% showed human effect as an intermediary factor in this relationship. So this means that any changes here will lead to improvement here and then it will improve the quality. To show you more on the human effect, so this is what we mean by human effect: workload, excessive workload, and then fatigue. 9% of the study showed this link. 14% of the study showed a direct relation between workload and quality, and then 22% linked fatigue to quality. Total of this is 45%. So in conclusion, you can see here that the relationship between poor ergonomics and quality deficits was strongly supported through empirical evidence, and this answered the research question number 1. And then multiple product process factors which are potentially modifiables were identified, and this is related to the second research question. And then fatigue and excessive workload were frequently identified as intermediary factor increasing the quality deficits. And this it does not answer completely the research question number 3, but definitely we need more research into understand the mechanism of this relationship. And then finally, you can see here clearly that there is a lack of studies with numerical analysis. Such analysis in the input variation and output variation, it will help us to develop mathematical models in order to estimate if we change the ergonomics by this much, how much change we will have in the quality. And this type of data, this type of analysis were missing. Thank you.
We have time for a couple more questions. What you've just seen is a combing through of the literature. Evie, can I get this mic, please? We've seen a combing of the literature from 4,200 papers down to a core of 73, which we've summarized. We're in the process of trying to write this up, but it would be actually very interesting for us to hear from you as the audience if you had questions or ideas or issues that you would like to have explained a bit more from this. And indeed, we do have a speaker here, please.
Hello.
Please introduce yourself if you don't mind.
Is it on?
I believe it's on.
Can you hear me?
Yes.
Okay, all right. My name is Syed, and I'm with the Occupational Health Clinics and CRE-MSD. You have identified fatigue as an important factor. Can you comment, or maybe Patrick can also chip in, with respect to the fatigue allowances in the development of time standards? How does this all play out in that context?
Actually, here fatigue, like some of the studies, they measured fatigue objectively. Some of them, they measured it subjectively. Some of them, they didn't even measure it. They just mentioned that fatigue could be an intermediary factor in the relationship, which shows that there is always confusion when the word fatigue comes in the picture. People, they're not sure maybe what is fatigue, maybe they don't know how exactly to measure it. And that's why you will find this confusion about fatigue. We wanted to do a separate analysis about fatigue. Actually, it's a separate analysis of this bigger picture. We wanted to isolate all the fatigue-related articles and just focus on them, just see how they measured it. Is it a good way of measuring fatigue this way? And just see what's more can be done in this particular fatigue-related articles.
I think we also had an interesting comment in Colin's talk around timing, right? You mentioned time standards. And what he found was that the more you load up your work cycle, the more likely you are going to have quality issues in that observation. But I think the definitive research hasn't been done there yet. And that's a need to be more precise in what we mean by fatigue, and also better at understanding this relationship between how much work we cram into a given 1-minute cycle or 30-second cycle, and the probability of error making based on the characteristics of the design of the job. So complexity is going to come into there. Product design is going to come into there. There's going to be a lot of issues at play.
Yeah, as a follow-up, I've seen some work done by Anil Mittal on kilocalories, like 5 kilocalorie standard, and then ILO work as well in terms of fatigue allowances. Do you know if those are being modified now or being researched?
I'm not aware where that particular research has gone. And I'm not sure if that thread of research was actually tied into quality. Did we have one of his papers in our set of 73?
Can you repeat again which paper?
The Mittal physiological
warehouses, a lot of work is done in warehouses.
No, I'm not sure.
Okay. I don't think, my recollection, not having the list in front of me, is that work has not been linked to quality performance at this point. So it wouldn't be in our data set here.
All right, thank you.
Thank you. We have a couple more minutes. Anybody want to ask a question, clarification? Please, yeah. Use the mic if you would.
Hello, my name is Enrique. I'm from the University of Waterloo. Currently with a startup that we're trying to track low back motion, assisting ergonomists in doing more precise assessments. And I remember you mentioned in the beginning of your presentation that ergonomists presumed that others, they are convinced about the importance of ergonomy, and then there's the system decision makers who are not convinced of that yet. So we know that research would sort of try to bridge that gap, but what more specifically do you think could be used in terms of bridging that gap between the two of them?
I think it's the whole, as you mentioned, conducting research, maybe conferences, publishing in management journals, making other than scientific journals more related to industry, inviting people from industry. And this is what we try to do in this workshop. We wanted to give our message to academic, plus like ergonomics, and to management and managers. Because I think, when you have a product, you have a good product. Even if it's good, if you don't promote for it the right way, then still you're not going to show the potential of your product. So I think it's the ergonomics responsibility to promote for their good product.
And looking at it from both sides, so the ergonomists have this research that they're convinced of, and they have to convince these people that this is actually a plausible work. Now, do you believe that it's lacking sort of a yardstick in between, such as, for example, if you come to me as an ergonomist and you tell me this pen is 7 inches long, and I'm just looking at it, I might choose to believe you or not, but if you come with a ruler and you show me that this pen is indeed 7 inches long, then I have nothing to discuss about. So do you believe there is an engineering gap between these two, sort of creating this yardstick to be able to prove that the ergonomists, in fact, have a plausible argument?
Yeah, exactly. I think providing empirical evidence with numbers, because managers and industry, I believe they like more numbers and profits and cost reduction, quality, productivity. These terms, they really get their attention. So if you show them numbers with improvements, real case studies, I think that will be helpful. Another thing, I think, as ergonomics and human factors society, I think it's not enough only just to, it's good to give the message and to show these relationships and these numbers, but also I think we need to do more developing tools, not just showing information. Developing tools, practical tools for their use, for the management use. I think this will be, this will get more attention.
I'll weigh in there as well. I think I'd invite you to speak with Judy Village, for example, or Michael Gregg, both of whom are trying to deal with not just tools for assessing posture, but tools for supporting design. And I think so long as we go in talking posture and pain, managers are less interested than if we're talking reliable quality production. We're talking in terms of the design requirements that they're dealing with, and that we talk in terms of their goals and their needs, and see ours coming along perhaps in behind, but that by supporting managers and what they're really trying to accomplish, we're going to get further in our own goals as well. So it's a goal-hooking strategy that we're advocating. But there are experienced people in the room who would have comments on that. Judy, did you want to weigh in? Since I'm pointing you out.
Actually, I was interested to ask you. It was a wonderful amount of data, and it must have been a heck of a job categorizing it.
Yeah.
And that would be one suggestion around writing this up is crisp definitions of each of your categories. But I was interested in whether many of the things that people were measuring, researchers were measuring, especially from the human factors side, were things that we were measuring because we know how to measure them, like posture and force and repetition. But are we measuring the right things to get us to quality? So I wondered if you had any comment on that.
Yeah, go ahead.
I think we're measuring what's easy, frankly. I don't think, like, the problem with this data is that it's a popularity listing, right? It's not necessarily what the most important pieces are. We don't know that. We'd have to be, drill in, I think, much more. It's certainly very revealing, though. 73 papers, that's a pretty big body of evidence. I think what's left, I mean, the problem of crispness, of course, is that this is essentially an inductive approach. So we're stuck with the definitions and the array of definitions that people are using. But I think what we see, if you want to put up one of the spaghetti diagrams, is dozens of opportunities to improve production quality and thereby also improve outcomes for the humans in the system. And those are the intriguing angles where I think action is potential. This is where I think managers start to get interested, right? Yeah, they're kind of interested in fatigue, but they're not really interested until they understand how it affects the goals that they're being rewarded for. So it comes back to organizational structure, the more macro issues of the organization. Thank you very much. Are there more comments? No, we don't. That's it. It's time for a break. Thank you very much, Ahmet.
Thank you.